I'm going to record this. Great. Okay. Well, thank you very much, everybody, for coming. Really appreciate it. This is obviously an introductory course to OpenNMS. For some of you, it may be too introductory. Others of you, you may not have come across OpenNMS at all, but I'm really going to try and start from scratch. I'm also going to try and cover the stuff that's most relevant to HPE. So there will be features that you aren't using, in which case I'm really going to skate over those and not really go into them in any detail. But I'm going to try and cover as much as I can of OpenNMS as a system. Let me share my screen. And obviously here you can see a screenshot of OpenNMS, but I'm not going to start with that. I'm actually going to start with just going through what the material is that I have. Now, hopefully everybody has been able to find the GitHub repository that I have put all the material on. And I've put in stuff for session 1, 2, and 3. I haven't done the rest of the sessions yet, but they will be being added over the course of this week. Now, just as by way of background, the way that I recommend you do this course is that you fork this repository into your own repository. You can do that using the fork button here if you've got a GitHub account. And what that will do is it will copy this repository into your own repository. And that will allow you then, if you make changes or want to do things with the examples, you can do that without having problems with my stuff. Now, the way I recommend that you do this is that I will be adding material into these sessions. So please do not modify these sessions in your forked copy. What I recommend you do is when you check out the repository, you copy the session into what's called My Practice Coursework, and then you do anything you want with that session there. I will never change anything in this My Practice Coursework folder, but I will be changing things in these sessions. And if you try and merge my upstream repository of your repository and you've changed these sessions, you'll have a bit of a problem doing the merge. So what I recommend you do is fork the repository, copy the session into your own practice coursework. That way you can do stuff with it, you can modify it, you can play with it, you can save it back up to your own repository and you won't interfere with my stuff. But at the same time, you can get the latest updates that I'm providing. So that's the basic structure of how the course material is provided. You'll see there's a little folder down here called Workup. That's basically where I hold all my stuff that I'm working on myself. So you can look at it if you wish, but really it's just workup material that I'm working on before I actually place the material into the actual sessions. Just a little bit further down, you'll see some stuff on getting started. And as a prerequisite for this, you should have installed already Docker Desktop and Git for Windows. Git for Windows will obviously allow you to check out this repository and do what you need to do with it, or check out your clone of the repository. And Docker Desktop is the way that we're actually running OpenNMS for the purposes of this little course. Okay. Eclipse for enterprise Java developers, you don't absolutely need this, but it's quite useful for editing files. And Apache Maven you may need later on as well, because I've got some examples that use a little bit of Java code, and you may find it useful to have Maven installed. But I'll leave you with those little exercises for yourself. Finally, I've got this final bit down at the bottom here, which is a page just talking about getting started with Git. It's a bit of an introduction to Git if you don't know Git. But the important thing about this is what I'm saying here about basically taking your forked repository and linking it to my remote upstream repository. So you, basically, if you work your way through this exercise, you'll see that you're able to link your forked repository with my upstream repository, and then you can further down at the bottom, it will tell you basically you can fetch the upstream. So if I have added new material in, you can fetch it, you can check it out, and then you can merge it with your own repository. So that's a way in which I can add extra material. You can merge it with your fork, and then save it back up to your own repository. So again, sorry if you're not very familiar with Git, but it's a useful skill to know. Hopefully I've provided you with enough material here just to allow you to use the exercises in a sensible way. Has anybody got any questions about that before I go any further?
No, sounds good. Just a small question. We will do the labs on our Windows PC, or if we have a VM, a Linux VM, we can also use it for the training.
Yes, you can use both. It should work on Windows and it will work on Linux as well. You will need to have Docker installed on the Linux distribution, but yes.
Okay.
Sounds good. Yeah, no, it should work on both. It's like everything. Sometimes things don't work, and it's like I don't know why it doesn't work, but yeah, all the stuff I've done has been working fine.
And for the PC environment, we need Git Bash. We need to have a Git Bash on the PC. Or?
Yes, that would be useful. Yes, that'll allow you to check out and merge stuff. Yes. Okay. And the download links are all provided there.
No, because I've got a brand new PC and I don't think I have everything on it. That's why I question you about using the Linux VM.
Yeah. No, that's fine. That's fine. And if you want to use Linux VM, that'll work fine too. It should. I've designed this so that it can work with both. Okay. So let's move on then with session 1, which is what we're going to do today. And I'm going to start off basically doing an introduction to OpenNMS and then go into a bit more material just that's describing how it's laid out and how we can actually use it. Now, again, some of you may know this already, but it's by way of background. Okay. So
hello. I have a little problem. I just got the invitation and I don't have this link for Git to set the repository.
Let me put it into the chat for everybody.
Yeah, good.
Thank you.
Mark. Okay, anybody else? Please stop me if you've got a problem. I can't always see if you raise your hand, so you do need to actually, unmute and interrupt me because I can't always see you've got a question. But there we go. Hopefully that's okay. Right. Okay. So what is OpenNMS? Well, let's start by just going through some slides just to give you a bit of an overview of OpenNMS as it is. So let me just share my screen. Can everybody see the slide?
Yes.
Great. Thank you very much. Okay, so this is basic introduction to OpenNMS. So OpenNMS started about 20 years ago. And the vision for it was basically to create a solution that would just work, that was relatively easy to install, but could provide quite sophisticated capabilities. Originally, it was started by some guys who had worked with Micromuse and also with HP OpenView, it was then. And they thought that they could do an open source version of the same thing. So that's what inspired OpenNMS. And the basic design goals are to make it very scalable, and that's something that it is good at. Make it extensible. Obviously, by being open source, it's possible for anybody to add code into it. But through plugins and through APIs, it's also possible to extend the features of OpenNMS. Obviously, it's open source. It's currently under the AGPL license, which is basically a copyleft license. It means if you do write extra code for OpenNMS, you have to publish that code. But you can make extensions basically any way you choose. And then finally, it's supported. And it's supported obviously through OpenNMS Group, but also there is a large community of users and there's quite an active set of support chat services you can use to get information on OpenNMS. So that was the design goals. Now it's got quite an active community. Lots of downloads, lots of people all over the world we can see are using the system. So we don't really know who is using OpenNMS. We obviously have customers that are paying us for support, but there are many other people who are just using it in their normal day-to-day life and supporting themselves through the community. What does it do? Well, OpenNMS, does event management, and by that we would mean traps or syslogs. Fault and alarm management, whereby we deduplicate those traps or events into alarms, which represent a state on a device. We do performance management, which can be just in the form of picking up statistics about CPU or I/O on interfaces. But we can also take that further and do traffic management, whereby we're picking up information on flows and giving very granular views of the traffic in a network. We can do network inventory management. Now, in that sense, we basically pick up information from the device as to what cards are fitted, what serial numbers are on the device, stuff like that. That will only work with SNMP devices that have the asset table enabled on the device. So it doesn't work for everything, but does allow us to get information from the network devices as to their physical construction. But also we have a very simple inventory within OpenNMS that allows you to put in very basic information about where it's located and information about the room it's in, the rack it's in, stuff like that. We don't pretend that OpenNMS is a CMDB system, but it does provide a basic level of CMDB information to allow somebody to monitor the network. And then going much further with it, we also have the ability to do correlation, and we have several correlation mechanisms reaching up to correlation based on machine learning, which I have to say is quite experimental. Now, in this course, we're really only going to have time to look at event and alarm management and performance management. We're not really going to go into a lot of the other features, but I will just describe them here so you know they're there. The other thing I'll say is that this week, we're going to look at fault and alarm management. Next week, we're going to look at performance management. So that's the overall structure of how these sessions are going to be divided out. Okay, so what does a complex OpenNMS install look like? And obviously we're running OpenNMS in our examples. We're going to be running them on Docker desktop, and it's going to be a very simple install. Basically, OpenNMS and a minion and a database is really all we'll have within Docker desktop. But you could extend that to a much more extensive deployment than of OpenNMS. And OpenNMS can be deployed as virtual machines, or it can be deployed as Docker containers. And indeed, we've done some work with yourselves on deploying using Kubernetes. All of the containers that we're using in these examples, they are Horizon containers. So they're the free and open source version of OpenNMS, but the containers themselves are structurally exactly the same as Meridian containers. And the stuff that I'll go through using Docker Compose, the basic configuration information will be the same with Kubernetes in the container itself. Kubernetes obviously is different to Docker Compose, but the information within the container will be the same. So hopefully this will give you some understanding of how the containers work. So in this diagram, what we can see is OpenNMS core. And OpenNMS core would normally work with Postgres as its database. Postgres is used to store the inventory information, configuration information on what devices are we scanning, what ports and what services are we scanning. And Postgres also maintains the real-time view of alarms and events in the network. And we use time series database to store performance data. And by that, we might mean the time to respond to a service pool, or we might mean performance data that's been pulled out of an SNMP MIB from a device. And out of the box, again, in these examples we're using RRD tool to store the performance data. RRD tools, RRD stands for round robin database. And it's basically a flat file that contains all of the time series usually up to a year's worth of data is held in that file. And then the file, once you reach the end of the year, it'll wrap around and start again. That's why it's called round robin. It means the file never grows any bigger than it would normally, that it would be at the start, and it gradually gets filled up and then it gets wrapped as we go around. So that's RRD, and we use that with a standard OpenNMS install. But we can also use Cassandra and other time series databases instead of RRDs. RRDs are absolutely fine if you've got a relatively small network, but if you've got a large network and you've got a need to back up and restore your system, then it's much easier if you're storing the data in a NoSQL database like Cassandra than it would be if you're trying to store the data in RRDs. And of course, the other problem with RRDs is that they are quite intensive from a disk perspective, whereas something like a NoSQL database would be less disk intensive, so better suited to a cloud environment. We also have Elasticsearch, which we can use with OpenNMS. That's really for archiving alarms in the long term. So we really don't want to keep a long-term store of alarms and events in our Postgres database. That's really for the real-time view of what's going on. We want to archive those off to Elasticsearch for long-term storage, and there's a plugin available to allow you to do that. It stores both the alarms and the events, but it also stores context around the device. And by that, we mean that, whenever you've had an alarm on a device, if you want to store that for a year or two, maybe in a few years' time, that device no longer exists in your network. Well, the data would have gone within OpenNMS, but within Elastic, we will store the name and type of the device along with the alarm. So you will always have that context with the alarms if you want to go back and look historically at what alarms OpenNMS has been dealing with. OpenNMS by itself can collect data straight from the network, but it also has a concept of minions, which are remote appliances that can collect data on behalf of OpenNMS. Minions basically will sit in their own address space, and they'll receive SNMP or logs or flows or telemetry data. Anything that's coming from the network can go to a minion, and then the minion can communicate back to the OpenNMS core, either using Kafka or ActiveMQ to talk to the core system. You don't have to have a minion. OpenNMS will work fine without minions, but the purpose of the minions is to allow OpenNMS to collect data from address spaces that it cannot directly see. So a minion will sit in that remote address space, possibly even behind a firewall, and will communicate back to OpenNMS. And once it's established the connection, it will then send any data that it receives back to OpenNMS, or it will poll on behalf of OpenNMS. And we also have this concept of a Sentinel, which again is for a very large installation. Often you don't need this, but the idea of Sentinel is if you had minions and you were monitoring in a remote data center and there was lots of data in the remote data center, you wouldn't necessarily want to send that all back to your core OpenNMS. You might want to keep it local in that data center, in which case you can arrange for the minions to send their data directly through Sentinel, and then it'll be stored locally in that data center in a time series database or in Elasticsearch. So that means that the data is kept local with the source of the data, and you're not sending a huge amount of traffic across your network where it could just stay local to the system. As far as OpenNMS is concerned, from a user's perspective, it doesn't look any different. It's just a way of offloading some of the work from the OpenNMS core. Finally, I should talk about the APIs on the top of OpenNMS. So we have a REST API. Most of the things that you can see through the user interface are exposed through the REST API. So you can do everything you can do through the user interface through the REST API. And the REST API allows you to obviously program OpenNMS from external sources to connect it to configuration management database or to connect it to a trouble ticketing system. But it also allows you to use a Grafana plugin to allow OpenNMS to communicate through Grafana to, and that way you can have remote dashboards running in Grafana that will allow you to see alarms and performance data. And if you had an environment where you wanted to provide, specific information to end users, customers, for instance, and you didn't want them to have access to the core OpenNMS, then Grafana is a very good way of doing that because it secures the interaction to OpenNMS and basically allows you to create dashboards for individual customers that will just allow them to see what they need to see. And that's very flexible, much more flexible than the OpenNMS UI is itself. We can also use what we call the Kafka forwarder, which allows you to forward both alarm data and performance data and event data, and in fact, a certain amount of inventory data as well to a remote system. So the system subscribes to the Kafka bus. It can receive alarm change events, which will keep their remote system up to date with the alarm table in OpenNMS. And it can also receive basic events that are coming out of OpenNMS, and it can receive performance data. And again, I believe that your plan is to use that in your integration to your own system going forwards. So that's a big brush overview of what OpenNMS looks like. In our examples, we won't be using Kafka. We'll be using ActiveMQ for the communication between the minion and the core, and we're doing that locally within Docker Compose. Does anybody have any questions so far? Okay, so let me move on to the next chart. So OpenNMS has a plugin architecture that allows you to write independent code and drop it in as a plugin into OpenNMS. Now, I'm not going to go into this in great detail, but I want you to be aware of what it is and how it works. So OpenNMS itself is built on top of a technology called Apache Karaf. And Apache Karaf uses something called OSGI, which is a standard for producing modular Java programs. If you know Eclipse, or if you know NetBeans, for instance, both of those IDEs are built on top of OSGI, but also quite a number of the modern Java enterprise servers, Glassfish, for instance, or Firefly, JBoss, are also built on top of OSGI. And OSGI basically allows you to define an application with all of its dependencies, but avoid the problems of having different dependent libraries for different applications clashing with each other whenever you try and run them in the same system. It allows you to separate the class paths for your various modules. So what that means for OpenNMS is that you can have an OpenNMS system and you can install a plugin on the system by simply dropping what is effectively a zip file, it's called a car file, into the deploy directory of OpenNMS, and that will start up a new plugin for you. Now, those plugins can contain code for a new part of OpenNMS. They can contain new user interface code that would provide you with new pages on OpenNMS on the UI. It can provide you with new REST APIs. And it can also provide you, which is probably most interesting, and we will try and look at this a bit later on, the ability to encapsulate a certain amount of configuration in OpenNMS. So instead of modifying the files that I will show you as we work our way through this course, you can actually encapsulate those files you want to modify in a plugin, which basically just wraps them in a zip file, and then drop them into the OpenNMS deploy directory, and those configurations will become part of the overall OpenNMS configuration. So it's a different way of putting configurations into OpenNMS, but it may be something that's useful for you if we are looking at potentially using containers and wanting to drop customer configurations into a container. So I'm not going to go into that straight away, but I want you to be aware that that is the value that the plugin architecture can bring to what you're doing. Okay, so in terms of OpenNMS's use cases, some of you may be aware of the business process framework, otherwise known as ETOM within the Telemanagement Forum. OpenNMS probably best fits in the resource data collection and distribution area. And certainly I think when you're working with other OSSs, that's the way I would characterize OpenNMS. It can be an IP mediation layer, which fits in the resource data collection and then passes data out through the Kafka interface or through the REST API to other systems within your architecture. But if you're using OpenNMS on its own, then it can still provide information to support all of these other processes. So obviously you can use it for doing resource trouble management, alarms and the like, but we can correlate those alarms into services and services affected. So we can again get a view of services, and we can interface with trouble ticketing and give a view of customer facing problems as well. And through the use of Grafana, you can also get customer specific views. So you can begin to see how OpenNMS can support a number of different services across an organization. And then through the reporting features, you can also capture long-term reports on the utilization of your network, and that can support your product lifecycle or support, adding extra services into your network or expanding the capacity of your network. This diagram basically says exactly the same thing for performance management, because we do performance and fault. So again, we collect performance data, can provide it to multiple different sources. Now, how do we collect the data? Well, OpenNMS can work at multiple levels within an organization. So clearly we can, monitor the physical infrastructure. We can connect directly to the hardware on a device and pick up data, directly from the controllers in servers. But we can also connect to the virtual machines, and we can do synthetic transactions at the level of the actual application. And if you think about it, and applications that, for instance, are showing up on people's browsers or on their little apps on their phone, the application itself is only really realized at the point where it's all brought together. So you could imagine there's an application that requires Google Maps, and it also requires data that's coming from a REST API somewhere else in the world, and it may require DNS, and it may require a number of other things that are necessary for that app to work. In order for you to know that that app's working, you need to be able to do synthetic transactions from the same location as the app that will exercise all of the services that that app uses, basically simulating the app, so that you can say, yes, this is working, or no, it's not working. So again, the minions allow you to distribute monitoring around an infrastructure and get a view of how is that service performing at this particular location. So you're not just saying, yes, the service seems fine at the data center. What you're saying is, yeah, it seems fine at the data center, but it doesn't seem fine at some remote location. And therefore, you can tell that there's a problem in your network, or there's a problem somewhere in between. So OpenNMS can do synthetic data collection using a variety of different protocols. Obviously, SNMP is the bread and butter. That's the main thing that OpenNMS does extremely well. But it also can use other protocols as well. So we can obviously just poll services using ICMP, HTTP, HTTPS, but we can also log into a page and run a page sequence monitor, which will actually go to various different pages in an application, check that response coming back is what you expect, and that allows you to monitor that that application is actually up as you expect it to be up. It also can pull data from that application. So if you had a REST API that was using XML or that was using JSON, you can set up OpenNMS to go to that REST API and to get the data out of the application using REST, and then pull it into the OpenNMS either performance management or fault management systems. So we can see we don't have to just use SNMP. We can use other methods to get data from the remote application. We can even scrape web pages to get data off an application if that's what people need to do. We can test the various network services. So we can obviously do DHCP tests. We can test if DNS is working. We can test FTP, etc. And we can also test email servers as well. So we can automate the sending of an email from OpenNMS and check that the email arrives. Again, just another aspect of what OpenNMS can do. We can use WebM and WSMan, particularly useful if you're talking to Windows servers to pick information up out of those servers using the WSMan protocol. So that's a WSDL-based protocol using XML that exposes information from, let's say, a Windows system, but can also be used with Linux systems as well. And we can use JMX. So for OpenNMS's own self-monitoring, it can monitor its own JVM, can monitor its own internal services using JMX, which is the Java Management Protocol. But we can also monitor external services as well, like Tomcat or any other thing we wanted to monitor using JMX on OpenNMS. If you have Nagios in your network, and you've got a load of Nagios services that you've set up, we can exercise those Nagios services as if it was the same as the Nagios agent. And therefore, there's a migration path here for people to move from Nagios to OpenNMS if that's what they want to do. I won't go in anymore. There's lots of things there to say. We have a VMware integration that allows us to integrate with VMware and understand what virtual machines are running on what underlying hardware. And we've sort of played around with OpenStack, but I have to say that there really isn't anything there yet we could talk about. But it's if it's an open source project, if you want to get involved, that'll be very useful. And finally, we do, folks. I am recording this anyway. I know you're wanting to record it, but I will be sending out the recording after this. And finally, when we discover a network, we can also discover the relationships between devices at layer 2 or layer 3. So that's the overall resource data collection within OpenNMS. Has anybody got any questions on this before I go any further?
No, that's clear for me, at least.
Okay. Great. Thank you. Now, we also do flow data collection, and we can also pick up streaming telemetry data into OpenNMS as well. So this just gives you an overview of how that works. Essentially, flows that come into OpenNMS will be saved in Elasticsearch because flows are basically documents. So Elasticsearch is the right place to put that data. So if we're gathering flow information from a network, that's where it would be put. And we have an ability to visualize that then in Grafana. But we also are able to pull up data from GNMI, for instance. So if you've got a router in the network that is using streaming telemetry, then we can send GNMI information to OpenNMS, and we can treat that the same as we would treat the SNMP performance data if we were polling that device. And that can be pulled in and visualized in OpenNMS. And any data that comes in through GNMI will also be available through the Kafka API and out to any other system that needs it. We'll make one caveat now about GNMI, and that is that it doesn't work with minions. So if you want to use GNMI, you need to just use a core OpenNMS to get that data. Still work to do to actually get that feature working in minions as well. So if we were gathering traffic statistics, this just gives you an idea of the way that would be visualized. You can see that we're obviously getting the basic information of bits in, bits out, but we're also seeing that on a per application basis, based on the IP addresses of where the flows are going, we can see what traffic is traversing your network. And that, again, can be useful for security purposes or just for planning purposes to know what traffic's in your network, where it's egressing and ingressing, and whether we're expecting it to happen. We can report information from OpenNMS, and the reports can come in two forms. So the first form is that, and for a long time, OpenNMS has had something called Jasper reports built into it. Jasper reports is very like Crystal reports, if you've ever used that. It's basically a reporting engine that runs on top of a database. You can write your own reports using Jasper Reports IDE. And then you can put them into OpenNMS, and OpenNMS can run them either on demand or on a schedule. And what they'll do is they'll produce a PDF document, something like this. This is just one of the example ones that we have that pulls the data together in some pretty way for you to display to customers. But we now also can do the same thing with Grafana. Jasper Reports is good, but it's a bit of work to get it working. If you just wanted a report based on an existing Grafana dashboard, we can do that as well, in which case it'll produce another PDF report to send out, but the PDF report will have been generated from the dashboard, which means that it's easy for you to modify what the content of that report is by just modifying the dashboard in Grafana. Finally, I should talk about network topology. So as we discover information about devices in the network, if they expose the correct SNMP tables, then a process called elinkd, extended linkd, basically collects the information about the devices and creates a graph of how those devices are connected together. And so you can actually, in your topology view, navigate to a particular device and then see the next adjacent devices to that. And you can move out further and further from the device. That gives you a way of seeing if there's a problem on a particular device, is that related to a problem on another device? Perhaps it's the same problem, but both devices are reflecting an alarm based on that problem. And again, when we're using our correlation engine, it actually uses the fact that the devices are connected as part of its inference. So it looks at an alarm. It says, are there any devices connected to this that are an alarm? Did those alarms happen around about the same time? If they did, probably this is an incident where there are a number of alarms attached to something has happened, and that allows us to correlate a lot of alarms into incidents and then represent a simpler view to an operator of what might be going on in the network.
When you say the devices are connected one to each other, which kind of a connection are we talking about here in this graph? Is it
layer 2 and layer 3
Ethernet interface?
So it's
I have 0 interface, something like that, or which kind of connection? Yeah, between the different nodes that we can see here.
So layer 2 and layer 3 are what we're talking about. So layer 2 is at the physical layer, so MAC addresses. So we can use the MAC tables on the devices to say what adjacent MAC addresses are connected to this device. We can use CDP and LLDP, which are protocols supported by a lot of routers, to actually determine what is the adjacent router to that device. That's at layer 2. And then layer 3, we use the IP tables to work out what adjacent devices are there at the layer 2.
Okay.
Good.
Thanks.
Sorry, are a multi-trunk aggregation protocol supported like MLT or something else? Can we discover trunks and aggregate ports?
Yes, to a certain extent. So the reality is that it doesn't discover everything. So it would go on a per case basis to work out whether it's actually going to find it properly or not. I can't say any more than that, really. Yes, it can, but not in all cases and not for all devices.
Okay, thanks.
So a little bit more about correlation. There's a number of things that go on. We'll talk more about this as we move forwards. But essentially, OpenNMS is an event-driven system. Everything happens through events in OpenNMS. So when we receive a trap, that gets converted into an event. Syslogs also get converted into events. OpenNMS itself, when it's polling services, if PolarD, which is the daemon that does the polling, detects that a service is down, that will generate an event. And ThreshD, which is the thresholding service, if OpenNMS is measuring a statistic and it crosses a preset threshold, that will also generate an event. So you'll have events corresponding to traps, events corresponding to syslogs, and events corresponding to thresholds or services that are up or down or have been crossed. Those are events. Now, the events themselves are enriched by information that comes from the inventory. So we will put extra information into that event and we will make it human readable based on information that either has come from the inventory or that comes from the MIB that's been used to define that event. But that's just events, and events are just something has happened. An alarm, on the other hand, is a state. So something is wrong in this device, and we're having lots of events coming in from the device to tell us there's a problem. It may be the device will continuously send us a stream of events saying, I have a problem, I have a problem, I have a problem. It's the same problem, but there are lots of traps coming for it. Alarm D deduplicates those traps into a single alarm for that device. And if a trap comes in to say that that alarm has gone away, then it will clear the alarm and the alarm will be deleted from the system. So an alarm is the state, the present state of the device based on the events that have come in. And if events cause an alarm to happen or cause an alarm to escalate, then the alarm will change its state. But if the event comes in and says this alarm is cleared, then the alarm will clear and it will eventually be deleted. We use something called rules as the business logic that drives alarms. And again, towards the end of this week, I'll talk a little bit about rules and how it works. But all of the stuff that we're going to look at on alarms, it's the rules engine that's actually keeping track of the state of alarms and keeping track of the events that are coming in and changing the state of the alarms based on those events. The other system that we have then is this OpenNMS correlation engine, which is actually, it's much more experimental, but it listens to the alarms in Alarm D and it listens to the inventory. And based on the alarms and based on the topology, which is in the inventory, it will correlate those alarms and it will issue an event that says these particular alarms are associated together. So that event that will come out of the correlation engine will be a situation event. And what that situation event will say is, here is a new situation, and this situation has got these 10 alarms associated with it. Now, in OpenNMS, a situation is just another alarm. But the difference is that a situation, instead of having a load of events associated with it, has a number of alarms associated with it. But it can still be managed as an alarm. There's a few other things we can talk about how we can enrich events, and we'll talk about that a bit more as we move forwards. But any more questions on this particular diagram? Okay. Now, another feature for correlation in OpenNMS is what we call business service monitoring. What this allows us to do is to create a graph of objects and show that they're related. Now, this is not the same as the graph that you saw previously. That was for the interconnectedness of devices. This is a graph that you would create yourself that says that these particular services that I'm monitoring are related to each other. So in this particular example, what we have is a three-tier architecture where we've got a service that's relying on underlying services. So you can see here we've got three web servers. They're obviously using HTTP, but we're monitoring in those services, that interfaces might be up or down, nodes might be up or down, or that the node may have lost a service. So we're monitoring on that particular service various things about the quality of that service and how it's working. And if that server went into an alarm state, then you might have an Amber alarm associated with that server. But because this is working behind a load balancer, then actually the service is not off. So that the net result is that you'll have a red alarm here, the web server is down, but at the level of the actual service, it'll be an Amber alarm because we aren't out of service, we're just degraded in some way. And so you can build quite a complex graph of alarms and relate those to the actual business impact of what has actually happened to the service that you're monitoring. Again, we'll cover that later on in the week just to give you an idea of how it works. But this is just another feature for allowing correlation within OpenNMS. And that is all I'm going to do with the charts. Are there any questions on that before I move on?
Just about the agenda, Craig. We will first focus on the alarming or on the metrics. Alarming, okay.
Alarming, yes.
Okay.
Yep. So we'll be doing that really in the sessions this week, and then next week we'll be looking at the metrics.
Yeah.
Okay. So let me share my screen again. So I'm just going to do a little bit of a demo on OpenNMS just to allow you to see around it. And then we'll take a break and then we'll come back and start doing some of the exercises, if that's okay. So let me just share my screen. So here we have the UI that you would see if you were logged into OpenNMS. And I'll just walk you around it. And this is actually the UI that you'll get in the demo systems that we're demonstrating. So this is not our sort of core demo system. This is actually what you can run yourself using the Docker Compose stuff. And you can see if I work my way around, we have this concept of notifications. And notifications are basically based on events. If there's an event that happens in your system that is critical, that you want to bring to the attention of somebody, you can set up an on-call schedule to say, these people need to be informed about this event when it happens. And if the people receive a notification of that event and don't do anything about it, it'll be escalated to the next person in that notification cycle. It runs off events. And to be honest, in normal usage of OpenNMS, you probably wouldn't be using notifications. You'd be using alarms. But if you want a means to actually inform somebody that there really is a problem here and you need to do something about it, then the notification on-call schedule is quite a useful tool to do that. But I'm not going to go into that in any great detail in this course. Then you have this idea of situations and problems or alarms. A problem and an alarm is basically the same thing. We don't have any pending situations, so I can't show you that at the moment, but I can show you an alarm. And under alarms, if we look at a particular alarm, this is the actual device. These are the events in the device. Let's just look at the alarms associated with that. We can see here that we've got two alarms. One is this node is down, and obviously the data collection on that interface is failed, probably because a node is down. Now, these alarms have underlying events, and the events are counted up against the alarms. So if I jump to this particular alarm, you can see this is the information concerning the alarm, but you can also see that these events have contributed to that alarm. And if there was more than one event, they would be shown in a list here of the events contributing to it. Okay.
So finally, here, Craig, this alarm was deduced, was generated by OpenNMS based on another, let's say, child alarm, right? The first alarm is the SNMP data collection on interface failure, and these alarms led to the creation of the second alarm, which is the major. Or maybe I misunderstood.
Well, you're partly right. These are actually two separate alarms that OpenNMS has generated separately, but in fact, a node will only be down if all the services on the node are failed. So data collection will have failed, but ICMP will have failed. There'll be no way of connecting to that device. So that'll be when OpenNMS says the node is down. So a node down alarm is as a result of data collection failing, but also as a result of ping failing and everything else failing as well.
Okay.
But there is no actual connection between these alarms. We're not correlating these alarms in any way. We're just that's how it works.
Okay, and regarding the first dashboard of the main, yeah, the home page, yes,
Yep.
that one. So we have 11 alarms with normal severity. What does it mean, normal? Does it mean no?
Well, actually, what we have is 11 systems that are normal, and one system has got an alarm.
Ah, okay.
And it's basically the same here as well. We've got, outages on some networks, some network interfaces, and the availability is, 94% because it's been there for a while.
Okay.
Okay. So
where can we have a look on those all systems listed here?
Okay, if you want to look at the systems, you can look at nodes. This will give you the full list of all the nodes.
Okay.
And you can look at the interfaces associated with the nodes if you want to.
Okay.
Okay. So let me go back to the first screen. So, okay, we have an alarm. We're going to go and look at the alarms. These are the alarms that we have on that particular node. We jump in and we'll look at this particular alarm. You can see that alarms have log messages, they have descriptions, and they have related events. But they also have this thing called a sticky memo and a journal memo. Now, I have to say, I always get these upside down, so forgive me if I've got this the wrong way around. A journal memo is, for this particular alarm, this is what we're doing. So this is just, for this alarm, we can save the fact that somebody is working on this particular alarm. But a sticky memo is, this would be the sort of, if this alarm ever happens again, what do you do for this type of alarm? So it allows you as a user to put in a bit of extra information, either on the specific alarm, somebody's working on it, or if you ever see this again, this is information that we want to keep with this alarm. So if this alarm type ever happens again, we've got that information. I don't have it in this particular integration, but we also can integrate alarms with trouble tickets. So you can see ticket state here. I haven't got a trouble ticketing engine as part of this demo, but if you did, you could, from an alarm, say, I want to create a ticket from this alarm. And also from the ticketing system, you could navigate back to the alarm that created the ticket and clear the alarm, clear the ticket using this UI as well. In terms of the alarms themselves, you can escalate alarms, you can clear alarms locally. If you wish, you can acknowledge alarms, which basically says, I've seen this alarm, I'm working on it. Okay. So that's alarms. If I just jump to the event associated with this, you can see an event is basically contains a lot of the same information as an alarm, but it's a lot simpler. So the basic information associated with an event, an event happens, you'll have a whole list of events. If I look at the events list, you'll see there's been hundreds of events have happened in the system. Some of them, the normal ones, basically mean we it isn't an alarm, it's just gone back to a normal state. But some of them are major, some of them are cleared. That's the event list, and the event list will just, it'll always grow. But the alarm list will just contain the status, and should be limited. And then you'll have a count of events associated with each alarm as more events come in. And you can see here, we've got our sticky and journal stuff here at the side, so you can see that if you need to see it. Okay, so that's broadly what alarms are. If we had an outage, then in this case, an outage is basically this particular device has been down for a long time. So it's been up at some point. You can see this little bit of green, but for the rest of the time, it's been down. And this gives you the ability to see the availability over time for that particular node. If the node comes back up, we'll get another green and we'll see how long it's been up. And we can obviously produce reports based on the outages and availabilities on the device. So that's outages. Services also have outages. So if we've got a service that's been out, then we can also get a view of how long that service has been out. We don't have any business service problems in the system at the moment, but again, if we had that correlation that I showed you on PowerPoint, then we could see that there are business service problems that's happened as a result of underlying problems in the network. And applications with pending problems basically is if you've got, as I showed you on the PowerPoint, a service which you're monitoring from multiple locations. And the use case for this would be in the States, we have a grocer that has a main data center and then has 1,000 stores. Those stores all have minions in them that are polling the services on the main data center. We would have an application associated with that data center, and then we'd have multiple minions that are polling that application. So applications with pending problems basically says, there will be one or more minions that are reaching out to this application or not seeing that application. So we're able to show that on the display. So finally, just on this, obviously, we've got the ability to place nodes on a map based on their latitude and longitude. It's a mapping service. Okay, I'm not going to go too much more into OpenNMS. We're going to look in detail at this stuff as we go our way through, but I wanted to just give you an overview of the main dashboard and then navigating around the system. Does that make sense? Any questions on that so far? Okay, now before we do too much more, I just want to show you one other thing. If you're logged in as an administrator, you will have access to this page, which is accessed through these cogs. And this page gives you the ability to configure OpenNMS. And there are various different things here, which we will go through over time in terms of how the system is configured and how we set up SNMP for the device. But you just need to know that this page exists at this point. If you need to make a change, you'll know where it is. Click on the cogs and it'll take you through to that configuration page. You can actually see the overall system configuration by clicking on system configuration. And that just tells you the Java virtual machine it's running on, and it tells you the services that are running and any problems that are happening in the system. But it just gives you an overall view. What version of OpenNMS are we running, for instance? So useful information if you need to find out from an OpenNMS system, where are you and what are you doing? Good, thank you. So we've been going for an hour. What I'm going to suggest is that we take a 5-minute break and come back, maybe slightly longer than that, maybe 10 minutes. Come back at it's about 10 past 10 my time. Would that be okay if we did that?
Yes. Okay.
Yes.
Okay. So 10 past 10, so it's about 7 minutes. We'll come back and we'll start again on some of the exercises. Thank you. Okay, so welcome back. I've restarted the recording, so hopefully you've all had a good little break. I certainly have, and we'll carry on with the exercises. Quick question: any questions on what we've covered so far before we carry on? All right. I'll take it. We're fine. So what I'm going to do now is begin going through some of the exercises that we've talked about, and let me share my screen. Now, as I said before, you need to get your own copy of this repository and you need to check it out and use it. I'm assuming that you know how to do that. I'm not going to go through specifics about that, but obviously there's a bit of tutorial material here to help you. But this first session is just an introduction to OpenNMS. So let me just first of all point out a few things that you'll find very useful. First of all, the OpenNMS documentation site. Okay, OpenNMS documentation is available at docs.opennms. Every version of OpenNMS has got its own set of documentation. This is for OpenNMS 32. And, you can work your way through this. But under deployment, we have, lots of information about how to install OpenNMS, minimum requirements, how you would install it. And we also have, under operation, a quick start guide that can take you through a lot of the initial pain of getting your OpenNMS up and running. Okay, so I point that out to you. A lot of the stuff I'm going to be going through is the same as in here, but here we'll give you a much more comprehensive set of things to work through if you're interested in doing that. So that's the first thing, the documentation. The second thing is that although I'm using Horizon 32, all of this will also apply to Meridian 2023. Obviously, you need to change a few names here and there, but basically everything I'm doing is equally applicable. Other sources of information that are available to you are the OpenNMS discourse server, which again, I'll open you up in chat. And you can see that there's lots of community support information here. And again, you can ask questions, and there are various tutorials and bits of information that the community have provided that will be useful and helpful, hopefully. Also, there's the Mattermost chat server, which again, you can sign up to and get community help with. Now, clearly, if you're an OpenNMS partner or customer, then you can obviously get lots of help through the standard support channels, but chat is available to you as well. The community is there, and quite often you'll get a quick answer from folk if you just put stuff in the chat if you sign up for a chat account. Setting up a production Horizon instance is covered in the documentation, but I just want to point out as well that there are actually some quick install scripts that are available to you as well. So OpenNMS Forge, if I open this in another tab, has a repository called OpenNMS Quick Install Scripts. And this will work with, the standard distributions. Basically, you download the script and you run the right one for your distribution, and it will install Java, it'll install the database, it'll install OpenNMS, it'll get a running OpenNMS for you on your virtual machine. It won't be, a very large scale OpenNMS. There'll still be tuning needed to be done to turn it into, a production ready system, but it does a lot of the steps for you if you just want to get something up and running quickly and you want to do it on a virtual machine. So that's the scripts you can use just to get OpenNMS running. This basically replicates everything that's in the documentation, but it does it for you rather than you having to work your way through and painfully change things. The other thing then to point out is the OpenNMS Forge Stack Play repository, which a lot of the examples that I'm going through are originally taken from this Stack Play repository. Now, what this is a set of Docker Compose scripts that are provided for setting up, in this case, a minimal Horizon. So that's a very simple OpenNMS. If I look at this, you can see it's got a database, it's got Horizon, and it's not got anything else. But if I go to, the full stack example, you can see that it has Zookeeper, a Kafka broker, it has database, it has Elasticsearch, it has Cassandra, it has Horizon, it has a Minion, it has Grafana, it has Kibana. It's got everything, right? So these examples are provided there to help you if you want to play about with the full capabilities of OpenNMS. I'll say that they should work. They don't always work because they aren't always up to date, but they're reasonably good. And all my examples are kind of based on these. So if there is something that you particularly want to play with that you can't find any examples with, then there are examples here and instructions on how to use them. And that's very useful. So 2 things to bear in mind: Stack Play, which has got a load of not Helm scripts, but Docker Compose scripts, and the OpenNMS install scripts, which you can just run on a simple server if that's what you want to get running. Okay, So what I'm going to do now is jump into our first exercise, exercise 1.1, which is getting started with a Docker Compose project. So I am assuming that you have checked out the actual project. I've got the project in Eclipse here. This here, OpenNMS tutorials 1, and then these are all the sessions. And if I just show you where that is on my machine, you can see that I'm, checked out close to Windows C. So C, devel, get repo. So I've checked out very close to the root of my system. Just a top tip here, do not check this stuff out anywhere where it's going to be stored in OneDrive or it's going to be on a network drive. Do it on the root of your system in the C directory and do it close to the C directory and make sure there's no spaces in the class path. Because if you have spaces in your class path, pain will arise. So just make sure that that's the case. So this is what I've checked out. You can see, and I've actually just created a project in in Eclipse to be able to look at it so that I can actually look at the sessions and see what's in each session. So this is my first session. This is the PowerPoint that I went through. This is the README. And then you can see that there's a particular Docker Compose project here with the Docker Compose file. You can see this is the file. And then the actual data that's used within Docker Compose for Horizon, for the minion, and then for the SNMP, which I'm using to do the little simulated servers. Okay, so that's how these examples work. They're Docker Compose examples. I will go into this more in the next session, but for this session, that's all you need to know. So assuming that you've checked out session 1 and you're in this folder here, minimal minion active MQ, then what you would want to do would be, I'll just jump to this, open a PowerShell window. Now, you will have to have started Docker Desktop. So Docker Desktop is installed and I've got it running, okay? And now what I want to do is I want to actually start this example. And I'm using Docker Compose up -D. Now the -D is important because that means that everything is going to start as a daemon, and eventually it will come back to my prompt, so I can do other things once I've got my Docker Compose up. Now, when you do this for the first time, it's going to take a while because it's going to download all of the images that it needs. And that is going to take some time, okay? So when you get going with this, the first time you do it, there'll be several minutes of downloading images before it does anything. And then it will create the images and it will start them. So these images have started. Hopefully everything's starting up properly. What I'm now going to do is I'm going to look at the logs for Horizon to make sure that it is starting up properly. So Docker Compose. Logs -F means follow Horizon. And this is just going to show me the startup logs for Horizon. And you can see that a lot is going on. Now, what is actually happening is that when OpenNMS starts up for the first time as a container, it is also going to create the database. And so you can see there's a lot of inserts happening here, a lot of SQL statements. That's happening because OpenNMS has detected that there was no database actually installed in Postgres, and it's created the database, and it's then going to start OpenNMS after it's created the database. So now we can see OpenNMS is starting up. It's done its first init on event-D, which is the first process that begins going, but it's now going to start up all of the other processes in the system. Now, this is going to take a little while. So I would encourage you, if you have already got this repository checked out, to actually go through this exercise yourself, okay, as I'm going through it. All the instructions are here. hopefully this will actually take you through. You can see I've done the Docker Compose logs, and eventually we will end up with probably the logs will stop because, you know, we'll have reached a point where we're actually starting. And this is probably what you will get at the end of the log, and OpenNMS should be booted at that point. So we'll need to wait a little while for that to happen. And in your case, you'll have to wait quite a little while for it to happen because it's got to download everything first. But it's gradually bringing up the various processes, and, you know, hopefully fairly soon we'll be in a place where we're able to look at the OpenNMS UI. Jetty is the system that actually runs the UI, so it's just starting up Jetty now. So it'll take it a minute or two before it actually gets that running. Now, you don't have to look at these logs when you start up OpenNMS. This is just so you can see what's going on, but also gives you a little bit of assurance that it's working right. If something was wrong, it would have stopped and you'd have had a message in the log saying what was wrong. You'd have to go and work out what it is, but hopefully this is working for you. So obviously, you know, Craft Startup Monitor is running, so we're probably up and running now. So what I'm going to do now is I am going to open a window and look at OpenNMS, and hopefully it's up and running. There we go. So this OpenNMS is running, and the username is admin, password admin. Obviously, in a real system, you would change that straight away, but for us, we just keep with it. And this gets our OpenNMS up and running. Now, I'm going to pause at this point, and I'm going to ask you, has anybody actually started to do this, and or is anybody actually, you know, running your system? Can I just ask if anybody's been doing this exercise?
Not yet. I was so far I was listening to you, and I was watching your desktop, but I can start.
Okay, that would be good. Just start it. You may not be able to finish in the time because it's going to take a while, but I would ask you, give it a go now, and we'll just check that everything's working for you. So if everybody could do that, just take, you know, 5 minutes and see if you can get the thing up and running.
Okay.
Sorry, quick question. What are minimal resources of the PC? Memory disk?
I mean, you should be fine with 8 gigs, 16 gigs would probably be absolutely fine.
Okay, thanks.
What have you got on your machine? Now, would somebody like to be brave and maybe share their screen just as they're doing this to see how they get on?
I can share my screen.
Okay, great.
I'm just trying to clone the Git repo.
Okay. You'd probably be better doing that just in the command line rather than using a Git to clone the repository. I mean, you can do it in Git, but I would do it in the command line. Do you have Git installed on your local machine?
Yeah, I have it.
Okay. So what I would suggest you do is just go to your C drive.
Yeah, I think it is done. It's done from Eclipse.
All right. Oh, you've done it. Okay, good. Yeah. Now, that may be fine, but the fact you've done it in your users may mean that you're running in a network drive. I don't know, but it's just something to be
No,
aware of.
it's on desktop,
Okay, all right.
this location. I directly go to the command line and say Docker Compose app.
No, you don't do it there. You do it in the, you need to be in a command prompt. So where's your folder? So what I suggest you do is, okay, on that, the OpenNMS tutorials, go to properties. Just click on that beside tutorials 1. And then get inside that session 1. Yeah, that's fine. Okay, and then right click. Just right click on the thing, and if you use shift and right click, if you got Git input installed properly, or shift, if you use shift and right click, you should be able to open a command window there.
Open with this there.
So shift. No, you don't want to do that. Do you want to open the file? Just clear that. Get rid of that. Just on the space. Just right click on the space.
Okay.
Okay. And then you want, so shift and right click, and that will allow you to open a PowerShell. So just go back from that. Just shift and right click. There you are, PowerShell window here.
PowerShell window here.
Yeah,
okay.
That's it. Okay. So now you're in the folder. So you just do Docker space compose space minus up space minus D and return.
Is this right? Compose.
That
Docker
is correct.
compose.
Yes, that's fine. Yep. Just press enter.
Yeah, done.
Right. Now, as I said, this is going to take a while because it's going to pull all of these images before it gets going.
Okay.
So what I'll do is I'm going to go back to sharing my screen. I'll go through a next step, but just leave that running in the background and we'll come back to you once it's finished. Is that okay?
Yeah, fine.
Yeah.
Right. Okay, so let me go to my screen share. Okay, so I've got my OpenNMS up and running. As we saw previously, you can see that I've got the system up and running. Now, what you'll see is that there's 2 nodes in this device now. And if I look at the nodes, what you'll see is the local host, which is the local OpenNMS, and you'll also see the minion, which has started up and communicated to OpenNMS and said, hello, I'm here. I'm in this location. So OpenNMS knows that it has a minion in a minion location, and it knows it has OpenNMS itself, but it doesn't know anything else. Now, what we're going to do in this first exercise is we're going to actually install this particular little network. We're going to discover this network. Now, the network itself is all being defined in the Docker Compose file. Okay, so if I, again, go to the right place. If I look at the Docker Compose file, what you'll see is that we've got the database, we've got OpenNMS, we've got a minion, and then we've got these little NetSNMP containers, which are the things that we're going to collect to detect. There's only 3 of them there, but that's fine. That's all we need. Okay. So our Docker compose file contains that. Those are the things that are in our network that we can find. So if we go back to the instructions.
Just one thing. The command docker compose up -d
Yes.
doesn't work on my CentOS VM.
Should do. Yes.
It should work, right?
It should do, as long as you've got Docker imposed correctly, Docker installed correctly.
It's not. It's a shared VM, so I cannot answer. I did not install everything regarding Docker before, but maybe I can do an update of my Docker installation. Update.
Well, the problem is that CentOS doesn't do Docker natively. Okay. Let me just DigitalOcean.
You can try a community edition of Docker. Docker C.
What version of CentOS have you got?
7.
Yeah, so DigitalOcean have got an example and the Docker compose. Yeah, so this will probably work. I use this as
okay.
Obviously, so that should work. Let me just paste that in the
okay.
chat.
Thanks.
Where is it?
Thanks.
Yeah, it may take you a while. So, but anyway, there we go. Right. So we're here. Okay. So we have our network, and they're in this example, there are 2 network segments. So what we've got is Postgres and OpenNMS running in one network segment. It can talk to the minion, but the minion itself has got a second port that's talking on the second network segment. So OpenNMS cannot see these NetSNMPs, but it can see the minion. But the minion can see those. So that's how that's set up. Now, what we want to do is we want to see, first of all, can we actually see the NetSNMP from our device? So we've got our OpenNMS server up and running. What I'm going to do is I'm going to just log in to that OpenNMS container. And I'm going to use Docker compose exec horizon bash. Can people still see my screen? That's important. Or are you not seeing my screen, or are you seeing the wrong screen?
No, we are seeing your screen.
Are you seeing me showing the example?
Yes, you're sharing a PowerShell window.
Yeah, good. Right. I suddenly thought I might not be showing that thing. So I've just used Docker compose exec horizon bash to get into the OpenNMS container. And what I'm going to do from here is just make sure that I can actually ping the NetSNMP device just to see that I can actually see it. So I can. So obviously it's on the network, which is exactly what we expect. Now, what I need to do is I need to discover that that network in OpenNMS. And what I'm going to do is I'm going to go, like I said, to this example here. And I'm going to go to, let me see if it's the right place. To network discovery. Okay. So if we go to the actual page, let's see if we can find the right place. Configure discovery. That's what I want. So configure discovery. So I'm going to this page. what I'm going to do is I'm going to include a range to actually discover. So if I go back to my example, you can see I'm going to add a range 127.20.0.1 to 127.20.0.254. So let me go back to my my OpenNMS. And I'm going to include the range. No, that's not what I want. Make sure I've got the right range. So I'm just finding the subnet basically. And the location I'm going to go for is just default, which is basically means I'm scanning this address range from the local OpenNMS. So I can add that, and that will discover the local devices. Now, what I'm also going to do is get the minion to discover devices as well. And in this case, the actual example is 127.20.2.1.
So you mean that both OpenNMS core and the minions will discover the same subnet?
Yeah, no, they'll discover different subnets.
Okay.
Okay, so this is the 2 subnet, and the other one is the 0 subnet. You can see there's 2 ranges here. I need to change that to console. I need to. Oh, that's not very good. It should allow me to edit it, but it doesn't allow me to edit it. I'll have to just delete it and add it again. So I don't want to use default. I want to use minion location 1. Okay. And I don't want to use specific address. I want to use. Okay, so I've got 2 ranges. One range that's local to the OpenNMS and one range that's local to the minion. If I save and restart discovery, it should be starting the discovery. If I look at the status and look at events, we'll actually see that there are events here that are corresponding to discovery starting, basically. So it'll work its way through that range of IP addresses, and hopefully over time, it will discover the nodes in our network. It hasn't got them yet, but it will get them over time.
Sorry,
Okay.
this discovery is based on the ping broadcast, I guess.
Yes. So
No
the first thing it does is it pings. Say again, sorry?
So no SSH, no SNMP at the moment, just ping.
No, it will do that, but it starts with ping. So it pings the address range. When it has a response to that ping, then it'll say, there's something there. I will do a port scan on that, and I will look to see what services are on that device. If it finds SNMP, then it'll start trying to integrate it with the SNMP. And if you think about it, if it does just a straight ping scan, it may find multiple IP addresses. There may be several IP addresses on the same device. Once it's got access to SNMP on that device, it's then able to associate multiple IP addresses with the same device. So it can begin to say, this device has got multiple IP addresses I can see in this range, therefore it's one machine. Okay. But it starts with ping. Should start with ping. I'm hoping it started. So, sorry, I'll go back to our events. Now, it actually may take a little while before it starts because it's possible that there's a delay on the configuration of Discovery. All right, initial sleep time 30 seconds. So that's why it's not doing it straight away. When OpenNMS starts up, it doesn't necessarily go and do a discovery straight away. It sometimes waits so that the whole of OpenNMS is started up before it starts doing the discovery. So you know, this is obviously taking a little while to get going. But hopefully it is actually going to come up with nodes. Ah, good, right, thankfully. Okay, so it is discovering stuff. And you can see that as it works its way through, it actually is using reverse DNS to find the name of the device as well. So in this case, that database that's got that name from reverse DNS lookup against the DNS server that runs natively in Docker, because I haven't put that information in. That's coming from the Docker Compose part of Docker itself. And there we are. We can see more devices are coming up. You know, the database, the minion, the Horizon itself, and these two ports here are actually related to the gateway within the network that Docker Compose uses. So let's see if it's done any more. I'm hoping that it's going to pull up the SNMP devices soon. Right, there we go. So that SNMP devices. So these are ones that are on this side of the minion. The ones on the other side of the minion will come up in a minute. Let's look at this particular SNMP device that is discovered. And you can see it's got the sys object ID, basic information from the SNMP. It's discovered that it's got ICNMP and SNMP on it, and it's discovered the IP address of the port. And that's all it will discover from this, to be honest. It won't get anything else. And it will start, you know, gathering resource graphs for the device. There won't be anything there yet, but, you know, let's just graph the selection, see if we can see anything. Yeah, there's no data there. So it'll be polling every 5 minutes. So, you know, if you leave this running for 20 minutes, then it'll start having data for you to be able to see.
Sorry, where SNMP communication parameters are stored? Like community SNMP version 3 credentials?
That is a very good question. And that was the next thing we were going to cover.
Oh, okay.
All right. So, okay. So that is giving us a scan. Okay. And, you know, it will discover all of these devices and you'll see, you know, they'll show up eventually. Right. Now, well, I'll cover this now anyway. I don't think it actually is in this example, but we'll cover it, just show you it. Under where we're going to do this next week, really, but you can see sorry, SNMP community names of IT address. Okay, so this allows you to put in the community names per IP address. So you can see at the moment they're public. Let me just find an address that I'm interested in. So interfaces. Let's just look at that one there. You can see that it's just using public and private as the community strings, but you could put another community string in here and it will use that community string. This page is also mapped onto a REST API, so you can push in community strings and you can set up community strings for a range of IP addresses. So you don't have to do it on a per device basis. You can do it for a whole range and it will use that. But this is where it's done. Does that at least start to answer your question?
Yes, thanks.
Okay, yeah, I knew that one was coming, but I'm going to do that next week, but our next session. Okay,
Craig,
right. So,
where can we change the default polling period from OpenNMS UI? I think the default polling is 5 minutes, something like that.
You can't
We can
even
change
do
it, right?
in the UI. You have to do it in the actual configurations, because it's not just the polling interval you need to change. You also need to change the settings on the RRD files so that it's storing the data using whatever different polling period you're going to use.
Okay. It's not straightforward from the
It's
UI.
not,
Okay.
no, it's not a straightforward thing, because how you're storing the data also is affected by the polling period. Which nodes are included in a particular polling period can be changed using the node categories. So if you set up 2 different polling cycles, but put a filter on those polling cycles that says only nodes in this category or in this cycle, you can specify some nodes will be done 5 minutes, some nodes will be done 15 minutes.
I see.
But you have to set up those polling cycles in configuration, and then you use the categories to change which nodes in which.
Okay, but anyway, by default, whatever the node, the node IP, the default applies for everybody, everything. I mean, 5 minutes. Okay.
Yes. Yes.
Okay.
Yes. Yes.
Thanks. Okay.
Yep. Okay. Yeah. Now, the other thing I wanted to say was, this discovery configuration file is actually contained within the OpenNMS directory. So you can push this in through a REST API. But if we wanted to look at OpenNMS itself, we're actually in the directory. So let's see where we are in the systems. Let's say CD. These are all the configuration files in OpenNMS. And I want to look at that discovery configuration. You can see that corresponds to what we entered in the UI. This is an XML file that's been generated from the UI, but you could also post this XML configuration into OpenNMS using the REST API, and it would give you the same result, basic retries and whatever. Okay, so we've got 10 minutes left in this session. I'm not going to cover anything else. Shall we go back to, who was it was bravely sharing her screen earlier on? Can we go back to that person? Sorry, I've forgotten your name.
Yeah, it's Shobha. I'm sharing my screen.
Shobha, thank you. Yeah, if you can share your screen and see how far you've got.
Looks like this share option is grayed out now.
Oh. Oh dear.
Oh, yeah, I got it. Got it.
Okay. Great. Okay. So can we see your command line, see how far it's got with the install? I think you've stopped sharing again.
Are you able to see now?
Yes, that's good. Okay. So do you want to do Docker compose?
Okay.
No, yeah, you could do that. Yeah. Okay. Yeah, so it looks like it's still starting up. So it'll be a little while before it finishes that. So it's probably not very much to see on your system at the moment. You can just watch that until it completes.
Okay.
But yeah, looks like it's working anyway. So it will come up, and then you'll be able to go on and do the rest of the exercise.
Okay, I'll follow the documentation.
Okay. Hopefully the tutorial itself will be enough.
Okay.
So we'll just go back to my screen. So what I've covered today was basically quite a gentle introduction. All right. Just to recap what we've done. We've looked at OpenNMS generally. We've sort of done an overview of the features that it has. Pointed you at various bits of documentation that are available to use. And I've also pointed you at some of the install mechanisms and also at the stack play repository. I've then taken you through a basic example, which is described here. Hopefully enough information for you to do this yourself. The network is more or less like this. I think there's fewer SNMP devices in it than are shown in this, but it's good enough. And the network has got OpenNMS on one side of the minion, and then it's got a separate subnet with these other containers on the other side. A little bit of description here on how to log into your container and do stuff, and then how to change the default configuration. Tomorrow, we will look at the specifics around doing more stuff with SNMP and changing that, but I'm not going to do anything more on that today. Any questions before we finish?
One question regarding Minion and Horizon communication. Is it HTTPS based or something else? Is it firewall friendly? Another question.
So out of the box, OpenNMS uses HTTP. So all of these examples are using HTTP. You can put you can use HTTPS. You can set up the internal Jetty server to use HTTPS. But generally speaking, we recommend that you run NGINX in front of OpenNMS and terminate your HTTPS on NGINX and then pass through to the OpenNMS itself.
Thanks.
Craig?
Any other questions? Yeah.
Yeah, in fact, I cannot update my Docker installation on my CentOS system, despite the link you shared with me, because apparently it tries to download a Red Hat image, and it detects that I'm running on CentOS. So finally, it does nothing. So you know what? I think that for tomorrow, I will switch to the PC environment. I will install PowerShell. I will install what Git bash. Why not? So, and I need to install the Docker also on the PC, I guess.
Yeah, use Docker Desktop.
Sorry?
Docker Desktop.
Okay.
It's this application here, Docker Desktop.
Okay.
Very simple, and that allows you to use Docker commands from the command line as well.
Okay. Thanks.
It's always difficult at the beginning because nobody has the right stuff on their machine, and
exactly.
CentOS can be made to work, but it is painful. So maybe you'll succeed.
I have Docker on my CentOS, but I don't have the Docker Compose command. I don't have this option. That's strange.
Okay.
I have another Docker visibly.
Originally, Docker didn't have Compose built in. You had to have a separate Docker Compose application. Mm-hmm. The later versions of Docker have got Docker Compose built into Docker, so that's what I'm using.
Okay, I understand.
Okay, any other questions before we finish the session?
Thanks a lot.
All right. Well, we're 5 minutes before the top of the hour, but that's good enough.
And can you tell me? Tomorrow, sorry, I was trying to include ranges of IP addresses, and can we do it through some configuration file, not in this menu of OpenNMS?
Yes, you can. If you see my screen, that configuration.
Okay.
Yep. Should work. Try that.
Okay, I will try both ways. Thanks. At least it's up and running.
Yeah, it's 90%. Good. Okay,
Sorry,
folks.
one
Well,
more question
yep.
about sizing. So what is maximum or recommended size of the managed nodes in single Horizon instance? Thousands?
I'm not sure I
hundreds?
understand the question.
Yeah, so how is it some limitation about inventory of the managed nodes in the single server?
Well, there's no hard limitation, but if you've got a big node or lots of nodes, then OpenNMS will struggle to pull all of them in any sensible period of time. I think for what you're running here, I would say running on a laptop, maybe 100 nodes probably is the kind of size you could work with without adding more memory or doing a bit more with it.
Yeah, but in a real production environment.
Yeah,
1,000,
so
10,000.
there's a sizing guide, which I think actually you guys have got a hold of. That'll give you an idea of that. It's not an easy question to answer, to be honest. There's various different things you need to worry about, but the sizing guide gives you some idea.
Thank you.
Okay, well, folks, really appreciate your participation. Any feedback appreciated. I'll try and get a copy of the recording, probably stick it up on YouTube, and we'll see you tomorrow for more of the same. And obviously try your exercise, see if you can get it working overnight. And if there's any problems, then we'll go through it tomorrow and see if we can sort that out.
Thanks a lot.
Okay, thank you.
Hey,
Bye-bye.
thank you very much
Bye.
indeed. Talk to you
Bye.
soon. Thanks. Bye.
Thank you.